Hello students. Today we are going to talk about a set of tools that have revolutionized how we build software. Computer aided software engineering or CASE. Think of it like this. Just as a carpenter uses specialized power tools to build furniture more efficiently, software developers use specialized software tools to build applications more efficiently. CASE is the use of software tools to automate and support the entire software development process. Let me give you an example. Imagine you are building a mobile banking app. Instead of spending hours manually drawing flowcharts on a whiteboard or a paper to map out the system's logic, a CASE tool lets you create professional standardized UML diagrams with a few clicks. Instead of writing every line of documentation and report from scratch, the tool can automatically generate and update these documents as your design changes, saving you countless hours of repetitive work. The core goal of CASE is to increase productivity, improve software quality, and reduce development cost. It achieves this by automating the tedious repetitive tasks that developers face at every stage of the software development lifecycle, from the very beginning of gathering requirements all the way through the maintenance. By using these tools, we can focus our time and effort on creative, problem-solving parts of software engineering rather than on the manual administrative task. We'll move on to the next slide. Now that we know what CASE tools are, let's explore their scope. The most important thing to understand is that the influence of CASE is not limited to just one phase of the software development. It covers the entire software development lifecycle. Let's walk through the SDLC and see how CASE tools are used at each phase. The first stage of SDLC is planning. At the very beginning, project managers use tools like Microsoft Project to estimate project cost, manage schedules, and allocate resources. These tools help them create a clear, data-driven plan for the project. The next phase is requirement analysis. In this stage, we collect and document customer needs. Tools like IBM Doors help a team to systematically capture, trace, and manage these requirements throughout the entire project, ensuring nothing is missed. What's the next phase? I hope you all know that it is system design. Once we have the requirements, we design the system's architecture. Tools such as rational rows or star UML allow designers to create professional UML diagrams. These diagrams serve as a visual blueprint, making the system structure clear to everyone on the team. The next phase is coding phase. This is where developers write the actual code. Some advanced CASE tools can even automatically generate skeleton code from the design diagrams, saving developers a huge amount of time on repetitive boilerplate tasks. What's the next phase, students? It is obviously the testing phase. In testing, we ensure the software works correctly. Automated testing frameworks like Selenium or JUnit allows team to write tests once and then execute them repeatedly with a single command. This makes regression testing fast and reliable, catching new bugs early. And the last final phase is the maintenance phase. Even after the software is released, CASE tools remain essential. Configuration management tools such as Git track every change made to the code base. If a new bug is introduced, the team can easily find out who changed what and even revert to a previous working version of the code. Based on the coverage of the SDLC, we can classify CASE tools into three categories: uppercase tools, lowercase tools, and integrated CASE tools. In the uppercase tools, these tools focus on the early stages of the SDLC, like requirements and design. IBM Doors is a great example. In the lowercase tools, those tools help with the later stages, especially coding and testing. An integrated development environment, which is IDE, like an Visual Studio, is a perfect example for lower case tools. In the integrated case tools, these are the comprehensive suites that provide end-to-end support from the entire SDLC. IBM Rational Suite is a well-known example for an integrated case tool. So, as you can see, the scope of case is incredibly broad, touching every single part of the software project. This holistic approach is what makes them so powerful. We'll move on to the next slide. Now that we know the different types of case tools and their broad scope, let's talk about how they all work together. Using a collection of individual separate tools can be inefficient. To get the maximum benefit, these tools need to be integrated into a single cohesive platform. This is what we call a case environment. A case environment is a unified integrated platform where multiple software tools, a shared database, and hardware resources are all brought together to support the software development process. It's the central hub for the entire project. Let's break down the key components of a case environment. Hardware, software tools, a central repository, a user interface, and an integrated mechanism. These are all the components of a case environment. Let's get deep into this. What is a hardware? This includes the physical infrastructure like high performance computers and powerful servers that run all the software tools and store data. Next comes software tools. These are the applications themselves, the modeling tools, the code generators, the testing frameworks, and so on. And a central repository. This is the most critical component. The repository is a shared central database where all the project's artifacts are stored. This includes design diagrams, source code, requirement documents, and test plans. And then comes a user interface. This provides a common interface for all the tools, making it easy for developers, designers, and project managers to access and use the environment. Finally, an integration mechanism. This is the glue that holds everything together. It ensures that all the different tools can talk to each other and share data smoothly. For example, a change in a design diagram is automatically reflected in the code generation tool. Let's use our e-commerce project as an example. In a case environment, the designers create UML diagrams and store them in a central repository. The developers then use a code generation tool that pulls those diagrams directly from the repository and creates the initial code. Meanwhile, the testers use an automated testing tool that also pulls information from the repository to run tests based on the latest requirements and code. This shared environment is what makes a case system so powerful. It eliminates duplication, ensures that everyone is always working together with the most up-to-date information, and makes the entire development process more efficient and less error-prone. It's the difference between a team working in isolation and a team working in perfect harmony. We'll move on to the next slide. In this slide, we will talk in more detail about how case tools provide support at every step of a software development lifecycle. The real power of case lies in its ability to connect all different phases, creating a seamless, traceable workflow from start to finish. First phase, as you all know, it is a requirement analysis phase. In this initial stage, we use tools like Jira to capture user stories, requirements, and features. These tools allow us to track every single requirement from its inception, making it easy to manage changes and ensure nothing is lost. And next comes the designing phase. With the requirement in hand, we move to design. Tools like Lucidchart or Enterprise Architect are used to create visual models of the system's architecture, such as entity relationship, which is ER diagrams for databases, or class diagrams for object-oriented systems. Next is coding phase. This is where the magic happens. Some case tools can automatically generate skeleton code from those design diagrams. For instance, a tool like Rational Rows can take your UML class models and directly produce the basic class definitions in the language like Java or C#. This saves a huge amount of time on a boilerplate code and ensures your code adheres to your design. Next is the testing phase. Once the code is written, we need to test it. Automation tools like Selenium are used to run test cases repeatedly. After every code change, these tools can automatically execute a full suite of regression tests to ensure that the new changes hasn't introduced any bugs or broken existing functionality. Final is the maintenance phase. Even after the software is released, case support is crucial. Version control tools like GitHub maintains the entire history of the project's source code. If a bug is found in production, we can easily pinpoint the exact change that caused it and either fix it or revert to a previous stable version. This kind of integrated support ensures traceability, the ability to trace a requirement all the way through the design into the code and finally to the test cases that validate it. This is how we ensure that our final products meets all the user needs. We'll move on to the next step. Now that we have covered the different types and scope of case tools, let's look at their core characteristics. These are the key features that make them so valuable to a software project. First characteristic is that graphical modeling. Case tools excel at allowing you to create clear visual representations of a system. Instead of abstract descriptions, you can build diagrams like UML class diagrams or DFDs. For a banking project, a DFD could visually represent how a transaction flows from a user's phone to the bank service, making the complex process easy to understand for everyone on the team. Next one is the automatic code generation. This is the powerful feature where case tool can take a design model like a UML diagram and automatically generate the basic source code. For example, a tool like Star UML can read your class diagram and produce all the necessary Java or C# code for the classes, including their methods and attributes. This saves a huge amount of time and prevents simple coding errors. Next characteristic is reverse engineering. This is the opposite of code generation. If you have an existing code base but no design documentation, a case tool can read the code and generate the design diagrams for you. Many modern IDEs like Visual Studio have this feature, allowing you to quickly visualize the architecture of a legacy system. Then comes the documentation support. Case tools can generate reports, user manuals, and other project documentation automatically. This is a huge benefit because it ensures that your documentation is always consistent with the latest version of your design and code. It also saves the team from a tedious and manual task. Next characteristics is project management. Many case tools come with built-in project management capabilities. Tools like Microsoft Project and Jira allows teams to schedule tasks, assign resources, track progress, and monitor the overall health of the project, providing valuable insights to the management. Final characteristics is the standardization. Finally, one of the most important characteristics is their ability to enforce standardization. Case tools can be configured to enforce specific coding standards and modeling guidelines across the entire team. This is vital for large projects as it ensures consistency and makes the code easier to read, maintain, and manage. These features all work together to reduce human error, streamline the development process, and make even the largest software products easier to manage. We'll move on to the next slide.